थर्सडे और सैटरडे है, पर मैंने इंग्लिश भी लिया था नेक्स्ट वीक से, मेरा मंडे ट्यूसडे रहता है, तो फिर वही माइनस साइंस डे, तो हमने अभी स्पेस डीलिंग मुझे स्टेशन के पास है, सेक्टर 5। बट हमारे स्कूल में एग्जाम बहुत लेट हुआ अभी से ऑगस्ट 4 ही होते हैं नहीं तो, बट अगस्त में फर्स्ट पीरियड होते हैं, हमारा फर्स्ट एग्जाम लेट करते थे, बाकी सब चलिए 2 पीरियड को प्रॉब्लम छाप चले जाते हैं, तभी ये मन नहीं होता और वो से 4 हम फिक्स से 4 है, 80 मार्क्स 80 मार्क्स के 4 है, हमारे 40 मार्क्स के 4 और 80 मार्क्स के 2।
Think about you. Where did we stop in last class? Last lecture, where did we stop?
Velocity.
Velocity. We started or we completed? We started. Any questions regarding the last lecture? Did we do uniform and non-uniform motion? You completed uniform and non-uniform motion? Okay. Okay. So now velocity is defined as rate of change of displacement. Okay. Or velocity is equal to displacement upon time. So it is during motion. Anybody use attending to the first time? So we had started the chapter motion. So where we defined the concept of motion and rest, you can actually see the video lecture. Okay. If you have any doubt, you can ask me in the next class. Okay. So today we'll going forward. So we already know what is displacement, right? What is displacement? Displacement is shortest distance between 2 points. Okay, in a given direction. So displacement has fixed direction, okay, and it is the shortest distance. So velocity is rate of change of displacement or displacement over time. So its unit is same as speed. So what is the unit of displacement? This is also length, maybe. Okay, it's in one direction. End of the day, it is length. So unit is meter. Displacement unit is meter and time unit is second. So it's in denominator. When it goes up, it will be meter per second. Okay. Then let's now understand what is uniform velocity. So velocity is a vector quantity. Okay, is it? Because displacement is a vector quantity, so velocity is also vector quantity. Now vector quantities has both magnitude and direction, right? So for uniform velocity, when will we say the velocity is uniform? In this case, the magnitude and direction of motion. Magnitude and direction of velocity does not change with time. With time. Okay? If the body is moving with constant speed in the same direction, then its velocity is uniform. Okay? So uniform or constant velocity. It means one and the same thing. So let's say example. Let's say body is moving with 50 km per hour. Okay, 50 km per hour. Now here we are expressing velocity in terms of kilometer per hour. This is the bigger unit of length and this is the bigger unit of time. Okay. So, and if you have to convert and towards east. Okay, if it constantly moves with 50 kilometer per hour in the same direction east, then we'll say this velocity is uniform or constant. What is non-uniform velocity? So since it has magnitude and direction, so if any one of the thing changes, okay, let us say now its velocity becomes with time, it becomes 60 kilometer per hour. Okay, towards east. So magnitude has changed, direction has not changed. Or if it was 50 kilometer per hour towards northeast. Now the magnitude is same, but the direction has changed. This is after some time, not at the same time. Okay, with time. Now both are changing. Let us say it slowed down to 40 kilometer per hour and its direction changed to southeast. With time. So if any of these changes happen with time, then the velocity is non-uniform. I've just written the example. So here this is the change in magnitude, but direction remains same. Okay, magnitude remains same, but the direction is changing. Here both magnitude and direction are changing. Okay, so change in velocity could be due to change any one of these two things. Okay, or both. When it is non-uniform. Okay. So at this level, we consider variable velocity of body on the first question. Right. So mostly we will be seeing this case only. Change in the value, but the direction may be same because we are going to study straight line motion. So all our motion in this book are going to be of this example. Unless it is circular motion, it will be specified. Then there is a third type of velocity, which we say average velocity. So what is average velocity? Yes, because in any motion between two paths, even if it is in the straight line, let us say Kopergane to Vashi, the main road. Okay. Now, when you go from Kopergane to Vashi, it is very rare that you will be traveling with uniform velocity. Real life motions are always non-uniform because it's idle case, okay, or ideal case. So, but real is non-uniform velocity because the traffic conditions are different. You will start and then more choke up, so you'll slow down. Suddenly free road, then your speed velocity increases. Then there is a traffic signal, then you're not moving only for some time. Correct? So from distance A to B, it is very rare that you're covering displacement at the same rate. The rate of change of displacement is not constant. Okay, that's why velocity is non-uniform. So this is real life. Motion is always non-uniform. Is that clear? So in non-uniform situation, we deal with what is called as average velocity. Okay. So average velocity is defined as net displacement on total time. Net displacement is the distance between the initial and final point. Okay, which would be displacement only. Because the initial and the final net displacement will be nothing but displacement. Or net means total. Net means sum total. Right? Okay. So this is what it is. So sometimes you will say net or sometimes you will see total, which it means one and the same. In your volume, it is given total, which is same. Okay. Right. It's a different case of average velocity. I'll just erase the top one. Like when I gave you the example from Copenhagen to Vashi, right? Now, if the traffic pattern is unpredictable, then the rate of change of displacement is also unpredictable. But what if the displacement is changing at a constant rate? Right? Like if it is increasing every second, the velocity is increasing by same rate, by 1 meter per second. Each second it is increasing by 1 meter per second. Okay. So when the displacement changes at a constant rate, right? So for example, let us say it started at an initial velocity u, and when it reached the destination, its final velocity was v. Let us say. View change करो ना view. Yeah. Standard में जाओ. और मल्टीपल जो रहता है जाओ व्यू में और भी होगा. कोई नहीं, बस एक ही साइड बाय साइड गैलरी करो. स्पीकर इसके नीचे नहीं, एक ही. ठीक है. But from going from U to V, let us say started with 10 meter per second, right? And reached here, say by 100 meter per second. And let's say there are 10 times its velocity changed, right? Let's say it reached from A to B in 10 seconds, let us say some distance. And each second its velocity increased by 10 meter per second. So 20, 30, 40, so on and so forth. Each second the velocity is increasing by 10 meter per second. So it is increasing at a constant rate, right? In such a situation, when velocity changes at a constant rate, then average velocity is given as, here the average is net displacement upon total time. So net displacement is full magnitude, right? In this case, it is u, मतलब initial velocity plus final velocity upon 2. So this is another formula for average velocity. Only when the velocity is changing at a constant rate. Okay. Average velocity is defined like this. Initial velocity, u is initial velocity where. So this is actually the average of two quantities. Average कैसे लेते हैं? Number of quantities divided by, I mean sum of quantities divided by number of quantities. Okay. So where u is initial velocity, v is final velocity. Okay. And since we are going to study about straight line motion only, for us, speed and velocity will be same thing. In straight line, the direction won't change. So then the distance and displacement, speed, velocity, everything will be same. So when we use this formula, V is equal to S by T. Okay. So depending upon the situation, it could be speed somewhere, it could be velocity somewhere. Okay. For straight line motion, same formula addresses both quantities, speed as well as velocity. Huh? This we have already given earlier. Okay. For straight line motion. This is under normal. Distance and displacement. Straight line motion in same direction, in one direction or same direction. Or same. Speed and velocity. Okay. S is the symbol for displacement. S means distance or displacement. Both you understand. Okay. V is used for both speed and velocity. S is used for distance as well as displacement. Right? नहीं लॉग इन कर रहा है क्या कोई बच्चा?
तो कर रहा था वो,
तो आज किया ही नहीं होगा ना उसने, फोन करके पूछो ना उससे।
वही प्रसन्न का भी कॉल आया था,
क्या
तो लॉग इन कर रहा है कि लेकिन आ नहीं।
लॉग इन रूम देखो बराबर दिया है, कौन सा जूम है, कौन सा जूम है वो चेक।
हेलो,
जूम आईडी बराबर है
आपण दिसतच नाही तो,